Hello everyone, my name is Avinash and I'm here to present Amber, which is a debuggable data flow system based on the actor model being built by our team at UC Irvine for the past 1.5 years. So first, let's talk about data flow systems in general and the current problems in this field. This example shows a data flow that finds articles related to disease outbreaks. It has operators like join, topic modeling that are expensive in nature. Now, such a workflow processing large amounts of data can run for a long time. Current data processing systems provide little or no feedback, thus leaving the user in dark about the status of the execution. So, in order to avoid any surprises, the users prefer to test the workflow on a small amount of data and hope that everything works fine on actual data. However, many issues occur only when large data is involved. Example, some data that triggers corner cases for your workflow. Therefore, a single corrupt data point may cause the workflow to fail on large data, and then the user has to do post-execution debugging using logs. Now, if we draw on our experiences of traditional programming and compare the experience of using logs versus using GDB for debugging, a few advantages of GDB are quite apparent. Compared to the experience of logs, where user is inundated with unrelated information, GDB offers real-time interaction and precise bug-related information that is easy to understand and track. Amber introduces such GDB-like runtime debugging experience in data flows. It does so by allowing users to interact with the data flows at runtime. Users can pause and resume the workflow at any arbitrary time. They can also specify conditions. Example, the user can specify the schema of input for each operator. If a tuple violates the schema, the workflow pauses itself. The user can then investigate the tuple and choose to skip it or change the parameters of the operator to allow it. A likely question that comes to mind is why build Amber from scratch and not build it on top of a widely used scalable engine like Spark? The reason for that is, in order to support runtime interactions with workflows in Spark, a two-way communication between drivers and executors is needed. And as Spark needs computation to be deterministic for fault tolerance reasons, it doesn't support such two-way communication. Amber is built on top of the actor model. Actors can be thought of as concurrent units of execution that communicate with each other through messages. All messages sent to an actor are kept in its mailbox and are processed one by one. We chose actor model because it is inherently parallel. Also, the only form of communication between actors is through messages and not shared memory, which simplifies concurrency control. It gives a nice abstraction to separate data and control messages. Also, recently there have been several good cluster implementations of the actor model, such as Microsoft Orleans, Aka, and CAF. Now, before we go forward, I would like to mention that we also have a demo paper being presented in this conference that demonstrates how we use Amber to support runtime debugging. I welcome all of you to attend that talk as well if you haven't. Now I'm going to present a brief overview of Amber. This slide shows how Amber converts an operator DAG into an actor DAG. The entire workflow is managed by a controller actor, whereas an operator is managed by a principal actor. Every operator is allocated multiple worker actors that execute the operator's logic. Note that the workers are distributed across machines. Let's assume that there is a long-running workflow that one is apprehensive about and wants to check if everything is fine. Amber lets the user pause the workflow, which means that the data processing is paused. The engine is still responsive to control messages, thus the user can investigate the state of operators. If he notices that some of the parameters of an operator need to be changed, he can go ahead and change them. Once the user has modified the operators, the workflow can be resumed. The new incoming data will be processed according to the new logic, and there is no need to restart the workflow. Of course, such interactive debugging necessitates that the interface is quite responsive. And for that, Amber needs to be able to process the control messages instantaneously. Now, this is a challenge in itself, and let's see how Amber solves it. Amber is a big data processing engine, and at any moment, the mailbox of actors are expected to be filled with data messages, and each data message can take a long time to process. So in order to expedite the processing of control messages, the worker delegates the data processing to a different data processing thread. The data processing thread shares state with the main actor thread. The incoming data messages are put in an internal queue from where they are fed one by one into the data processing thread. This leaves the main actor thread free to handle control messages. When pause happens, the data processing thread saves its state inside the actor and quits. Another powerful feature supported by Amber is conditional breakpoints. Amber accepts database predicates from users that it continuously evaluates on the incoming data, and when the condition is satisfied, the workflow pauses itself. In this workflow, a company is monitoring customer complaints being received per product on an app store. If suddenly there is a spike in the number of complaints, it may mean that the product is being maliciously targeted or the sentiment analysis operator is malfunctioning. Since we want to detect such cases, we set up a conditional breakpoint to detect a spike in complaints. An interesting aspect here is that the detection of a condition may require collaboration between actors on different machines. We call this a global breakpoint. For example, in this workflow, the 1 million complaints threshold needs to be collaboratively detected by all the workers of the sentiment analysis operator that may be on different machines. The principal coordinates the detection among workers and assigns them local targets so that the workflow pauses at exactly 1 million total complaints. When the workers produce 1 million tuples in total, the controller actor pauses the workflow. Lastly, let's discuss fault tolerance of Amber. Since we allow arbitrary runtime interactions with workflows in Amber, the computation becomes non-deterministic. Fault tolerance in Amber doesn't just mean producing the correct results in presence of failures, but also recovery to the state before the failure. For example, if the workflow was paused and a failure happened, the workflow should remain paused after recovery. To do this, we log the order of control messages received by each actor with respect to the data messages. And in cases of failure, the data and control messages are replayed in the same order for every actor. Now let's go over a few experiment numbers for Amber. We scaled Amber up to 100 machines and 1 terabyte data and ran workflows containing expensive operators like join. We ran the same workflows on Spark. The performance of Amber was found to be almost similar to Spark's RDD API and quite comparable to Spark's newer DataFrame API. Responsive interfaces are an important requirement for interactivity. Amber provides sub-second latency in processing of control messages. As can be seen in the box plot, even on a 100 machine cluster and 1 terabyte data, pause message was processed within 800 milliseconds by the workflow. Similarly, resume also took only milliseconds to be processed. Conditional breakpoints in Amber have little overhead on processing time and can be used in production. We put a breakpoint on the output of filter operator in the shown workflow with a condition that the workflow should pause after filter operator produces 100 million tuples. When we compared the time taken by filter operator to produce 100 million tuples in presence of breakpoint versus in absence of breakpoint, the difference was less than 1 second. So in conclusion, Amber is a scalable data flow engine based on the actor model that supports runtime interactions and debugging. Thank you, and we welcome your questions.